Well, hello friends. Welcome back to browser hacking. Today we are going to take a look at the second ACID test, or the ACID2 test for short, which is a browser standards conformance test, which sort of tests various things about your browser and sees if you can render something correctly. And let me bring it up in Firefox just so you can see what it's supposed to look like, and we can compare it. So this is the sort of where we're supposed to get to, and if we take the test here, this is what we currently got. So as you can see, we're pretty far from the intended result. Now, this is still a lot better than what we had just a few days ago when it couldn't render anything at all, but obviously there's a bunch of work to do here. So I figured today, I'm just gonna start looking into some issues here and fixing a couple maybe, and then we can see what we find. And I'm not really familiar with debugging this test, so we'll see how it works. But I guess we will start by just inspect element over here, and maybe we can see what we're working with. Or actually, maybe we should open the source instead. So it's a bunch of CSS followed by basically a pretty simple document. So at least in terms of markup, so we have a couple of divs, and then I guess there's a nose div, an empty div, a smile div, chin, eyes, forehead, and so on. And I don't know if that is the nose or the mouth or what, but we can figure that out. This, I guess, is probably the chin. But maybe we can take one of these and figure out what the heck's going on with it. So one thing is that the output is way longer than it's supposed to be. So let's start with that. So we'll just take a look at the DOM tree here. And looking at the body, so that's the intro. Hello world. Okay, so we can see like the little magenta rectangle around the item or the element that I select here. So this is the picture container, I guess. Contains the whole thing. And in there we have a table and some class, some block quote. Here's the forehead. So the forehead is supposed to be here, but we're not rendering it correctly, probably because of the background URL thing. I don't think we understand a background property with a URL in it. That's something we could do better. And then we have the eyes, which are nowhere to be found. And oh, and there's an object element in there, with another object element inside of it, and another one inside that. That doesn't even seem right. I think something's not going right there. Might be a parser problem, but basically, or maybe that's okay, but you're supposed to be able to include an image using an object element, and that seems to be what they're doing here. So they're doing object data and then supplying some base64 encoded PNG data. Okay, so that's the eyes are these basically PNGs, or a PNG maybe. View image. Yeah, it's this PNG right here. So maybe we can do an object element, and then the nose. So the nose is very long. Why the long nose? Is the question we must then ask ourselves. So let's see. What are the properties that apply to it? Height 60%. I bet that's related. Min height 80%. What's even going on here? What are those things, by the way? The forehead. think we skipped over this one, the block quote first. So why doesn't that one work? Because this one should just have a yellow background. We should be able to do that. Okay, so this one has absolute positioning. So we don't support absolute position quite correctly just yet, but I think it's probably this, actually, this class selector. Okay, well, let's not get carried away. Let's do the long nose thing. So why is the nose so short here? Let's see. So this is the nose, and I mean, this is side. He should be 36 pixels tall because we have a height of 60%, but it's constrained by a max height of 3m. So we could probably constrain it by the max height. Then we have max height here. Max height 3m. Yeah, so I think that would be a solid fix to just do. It'll be in layout block. We compute height. So this is the specified height, and then we'll grab the specified max height. And let's see, so if the specified height is not auto, then if the, let's say, wait, hold on. So the use height becomes the specified height, 2 pixels, oops. And then we use that, but before we use it, we constrain it. So we say used, if specified max height is, if it's not auto, but it's some value that we can actually use for something, then used height is min of used height and specified max height 2 pixels for this layout box. Okay, so I think this should constrain the height of the nose to 3m. We'll see. Oh, that's some hot tea. So I have a copy of the test here. We can use that. All right, that's successful, I guess. Test is a bit shorter. And this guy is here. I don't know who he is, but it's nice to see you, little squiggly guy. Okay, so let's just commit that. Libweb constrain block height by the max height if specified. Okay. Oh, I guess we should have Clang formatted before doing that. Okay, so that's one nice little change. And then there was that weird selector thing that this guy right here, yeah. So we definitely don't support that type of selector. So let's see what we do if we just dump out the selectors. What do they currently look like? So if we dump the style sheets and then we search for oh, well, there are not so many. Maybe we can just eyeball it. Here are the eyes, the forehead and okay, so it's probably these because we have tildes right here. That's so weird. Oh, right, yeah, because it thinks that it becomes an exact value match selector. So it tries to look for a class with exactly, or it tries to look for an attribute with the attribute class tilde having the value 1. But actually this is a attribute contains selector, right? So it means that in a space separated string, if you like take the attribute and chop it into strings, then one of those strings is this one. So let's implement that. Where do we go for that? I guess in our selector. So currently we have these types of selectors. None has attribute. I mean, these are the attribute selectors. So none, I guess that's just an empty value. And then we have has attribute and exact value match. So we'll take contains attribute maybe, or contains. Yeah, contains is fine. So, and then in our selector engine, the way that we match this, exact value match. So if we have a contains simple selector, then what we'll have to do is check if the if not element attribute component attribute name split by spaces contains slow. Let's just call that because it's informing you that this is a linear lookup. It's just a scan across a vector. And we just want to check if it contains the component attribute value. Right, and if this is not a match, then we return false. Because the whole selector matching engine is it just tries to find a reason to fail. So this is the reason to fail here. If the space split string of the attribute, targeted attribute, does not contain the attribute value. Okay, and then break. And then how do we parse this guy? Exact value match. Now, the CSS parser is totally ad hoc, and it's not very good, and it's not very compliant to any kind of standard, and it's going to have to be replaced by a spec compliant CSS parser, which will be very similar work to the ongoing work with the HTML parser. But I think here the interesting part here is making the selector engine know how to match one of these selectors, which we just did. So now, like, if we just parse it here in the ad hoc parser, that'll be fine. And then when we switch to a better parser, it will just work. So currently, we only support exact value match attribute selectors because we just checked for this. But I guess we can also do something like if the current one is that, or the current one is a tilde, and the upcoming one is one of those guys, then if cha is cha, then it's an exact value match, else if cha is tilde, then it's a contains, and we'll have to swallow one extra byte just to make sure, because we only peaked here, right? Like we didn't consume. So I think that should be enough. Oh, I have to actually use this in a thingy somewhere. It's just stringification. Oh. Oop. Okay, well, that's a little bit different. Don't know if it's better or worse, but let's see what the style sheets look like now. So if we just search for contains, we can see that we have parsed a contains selector where it checks the attribute class for presence of the string 1. So that looks good. I think that's probably okay. And this thing is supposed to be black? I'm not even sure what I'm looking at here. Is it the thing in the middle, or what is this guy? Oh, the address in the middle, that's what it's supposed to be, a little bit yellow. Wonder if we can see the address element here. When did this test come out anyway? Let's look it up. 2005. All right, so that's about where we are with CSS standards compliance, pre-2005. But we're moving forward little by little here. But I remember when this test came out, and the browsers at the time, they were racing to be the first to support it. I think maybe Opera was first, as the meme goes. Opera did it first. But if I recall correctly, then WebKit came soon after, and KHTML not long after that. And then Firefox eventually caught up, I think, but maybe I'm misremembering. I don't know. Anyways, we have that block quote thingy, and then the address thingy inside. Wonder why I'm not seeing anything magenta encrusted here. Let's dump out the layout tree and take a look. So where do we have that block quote? It's 0 pixels tall, and the address inside it is 0 pixels tall as well. That's a bit weird. So these guys are 12 pixels tall. This one is also 12 tall. Why are you 12 pixels tall? It's because of the 12 pixel thingy here. So probably this rule here doesn't match. Let's take a look. The block quote did not have any height specified, but the address does. Okay. So this selector might not be matching. What is that selector? Class contains 1. Wait, hold on. That is a mouthful of a selector. Second line of face. That's the block quote, right? So class 1 or class contains first. So it has to be containing both 1 and first. That one should be a match. And the second one has to contain both second escaped space 2. Okay, so probably the escaped space is the issue here. So the space here tells us it's a descendant selector, right? So we need something that matches both of these two attribute selectors to be a descendant of something that matches both of these two. And this one contains both first and 1. And then the descendant here matches class is second 2 and second 2. But I bet you that if we dump out the selectors, then we did not care about that / escaped space. Second / I bet it's verbatim. Yeah. So we are looking for an exact value match for the class attribute, with the value being second / space 2. So we need to teach the ad hoc CSS parser about / escapes. But maybe first thing we should do here is just commit the contains attribute selector, because it's really nice and contained, self-contained. support parse and match basic contains attribute selectors. All right. And then, so when we're parsing the value of one of these guys, how do we do that? I guess here we're looking for the end of the attribute selector, right? So we're just going until we hit one of these guys, starting here to here. So the value is accumulated here. All right. So I think we can do something here like if peak, or actually if ch is backslash, oops, backslash, then and oh, actually if it's a backslash we should just get the next one. So just as a quick hack, what if we just do consume one? Just fetch the next character and then append that to the value buffer. ACID2, clickety clack. Okay, so I wonder if we actually achieved anything here. How do we find that? I guess we look at the okay, we can see now that the address element has a height of 12 applied to it. I'm still not seeing any magenta when I select these, so let's do a layout tree dump. So here's the block quote. The block quote is now 12 pixels tall. That is great. And he is at a really, really far away y coordinate. That's a bit weird. Why are you so far away, dude? I don't even know where he is. Also, we don't support horizontal scrolling yet, so it's kind of a limiting factor. But block quote and the address is also really far away vertically. Why are you so far away vertically? So we'll place you after this bad guy right here. So that would be p-class bad. That'll be this guy. Or no? Wait, back up. No, it'll be this guy. Because he is the sibling of the block quote. Right. So this guy right here, he's not particularly tall. So why does the block quote become so offset? I simply do not understand why your y coordinate is so far away. Okay. His sibling is at a reasonable place, yeah. But the table sibling, okay, so this one was, never mind that guy. But the table sibling is also really far away. And this div class picture is also really far away. Oh, wait. I'm being stupid. Right, the way the test works is you start up here and then you click this thing and it's a scroll. So it scrolls down to a different part of the page. So that's why the y coordinates are so such large numbers, because we're just scrolled down. Okay, well, I almost confused myself there. So, all right, so 1163, that's the picture div. And then we have the table, or the block quote is at 1219. So for whatever reason, we're not painting the magenta. Maybe that's just something in front of him. But the coordinates here look good. So I think that's good. And we definitely did a good thing with this, although I guess I don't love the way, do we have any kind of escape handling anywhere? No. And we'll do something like this. Or, you know what? Let's just do it this way. And let's see, this is a hack to support. This is a hack that will go away when we replace this with a big boy CSS parser. Yeah. Live web. Support, ignore backslashes. That. In attribute selectors, this makes us at least parse selectors like foo equals bar baz correctly. The solution here is quite hackish, but the real fix, current will come when we implement a spec compliant CSS parser. Okay, so what do we do next? Maybe the object element stuff. Let's see what else we're looking at here. Maybe we can make this thing load automatically, by the way, so I don't have to jump through those hoops. If we just do something like that. Oh, come on now. This doesn't do what I wanted it to do. You loaded welcome. Why did you load welcome? Well, that's really weird. Okay, I don't know how that works. So it loads welcome for some reason, but the fragment is here. Okay. Well, then maybe we can at least make it a bookmark, because I don't want to dig into why this is behaving so weirdly right now. Welcome HTML, but we can at least put like a little bookie mark. ACID2. On ACID2 HTML top. All right. Click. There we go. Okay, so what else can we look at in this thing? So yeah, we could do the object thing. Or what else is there? I mean, there's all kinds of things, right? But what's up with the... So did we establish what that thing was in the middle? Is that the nose? Yes, that's the nose. Okay. Then we have some empty stuff on the smile. This is the smile right here. I feel like something is missing in the smile. So the cheekbones of the smile are, what are they exactly? It's some div span m strong. Okay, so what do we have there? We have a div span m strong. Okay, so what's up with the strong here? Why do we not see it the same? We have basically the same properties. So maybe the M, what's up with the M? The M is missing the border top, border bottom. We're not seeing those here. So why don't we get those? It's supposed to be class smile div span M. So you have class smile, div span M. Why don't we match that selector, bro? Let's look for it. So it had a smile in it. Class smile. Here, class smile div span M. Oh shit. Invalid CSS property ID. Okay, so I guess we don't actually, maybe we don't actually support the border top and border bottom properties. So we have border top width and border top style, but not border top. So all of these like CSS shorthand properties are kind of irritating. Because there are so many different ways you can express the same properties in CSS. There's like border and border top style, border top width, and so on. But basically the border property is, it means set the 4 edge borders to the same property, and then border top, border left, border right, border bottom make up the border property. But I think we only care about the border. Where did we do the shorthand stuff? Here, so border. And really what we should be doing here is doing this on a edge by edge basis. So border style, border width. So what we had was border top and border bottom, right? Let me just double check that. Or we can see it here. Or no, we can't see it there. Border bottom. Where are you guys? Where's the smile? Where's that smile? Here, border bottom and border top. So border top, border bottom. Wait, how the heck does this work? Set property border style. Oh, and then it assigns to each of the individual ones. Oh, that's a bit goofy. Okay, I get it. Okay, so I guess for here we want to either choose an edge or do all edges. So edge, top, right, bottom, left. Or the magical all edges. Okay, and then we can have something here like edge. Okay, so if edge is, or wait, how do we do this? If edge, if, static, oh, wait, what is it that I want to say? I want to say if is edge, should do edge. Matches edge. I don't know what's a good name for this. Has edge. These names are all terrible. I just want to. Okay, let's not get hung up on the name here. Edge, edge. Edge, edge 2. Matching edges. Okay, these names are shit names. Contains. Okay, we're going with contains. Right. A equals B, or B is edge all. Yeah, that's what we're doing. Contains is officially a terrible name for this, but for some reason, a good name for this does not come to mind right now. But yeah, we're just going to want to do this exact thing for all of these guys so that you can optionally specify an edge, or if you don't specify an edge, you get all edges. So then here, that's the right edge, the bottom edge, and the left edge. The edgy lefty. And the shorthand stuff also needs a revamp. There are a lot of things in this engine that need revamps. We're kind of monkey patching a little bit. The reason that I'm okay with monkey patching a lot of things in libweb especially is because there are so many different subsystems in this browser engine, and it's really hard to make any kind of visual progress if you're not willing to monkey patch in some subsystems while you're doing the right thing in another. Now, if we were monkey patching all subsystems in parallel, that would not be good. But it's almost like we have sort of like the good boy subsystem, which is currently like the HTML parser, and to an extent the layout engine is increasingly becoming a good boy subsystem, and then we have some bad boy subsystems like the CSS parser, which is just very ad hoc and not very serious. And it's okay for it to be like that because we're still improving the good boy subsystems while sort of paying a little bit of technical debt here in the CSS parser. But we already know what the fix is, which is just simply to replace it with a better parser eventually. And if we establish the correct interfaces between these things, then swapping out the parser will not be terribly difficult. Like swapping out the HTML parser for a new one was not terribly difficult because we already had the DOM interfaces were basically the same before and after. So that was really good. Okay, so now this becomes, what we want to do here is we want to do set property expanding shorthand. So what's the way to do this? I guess we can do style property ID border top. Okay, yeah, so we can do it this way. Property ID, and then we check if it is one of these guys. And we need to actually make those values show up somewhere. So where's that? That is in libweb CSS properties JSON. So we have the border top, which is a, oops, it's a shorthand, and the longhands are same as border, actually. So border top width, top style, and top color. All right, so chicka. Oops. Okay, there we go. And we ninja that thing, and that should give us, yeah, some enums here to work with. So that's great. But what's going wrong? I guess that part was wrong to begin with, and then too few arguments. Right, so then we gotta pass the edge up to these guys. And the edge is gonna be switch property ID. Case CSS property ID border top. Edge is edge top. Briac. Oh, we need to pass some more edges down here. So I wonder if this will do the trick, and we should get something for the smile now. I don't know what it's going to come out as, but at least we should recognize those CSS properties as borders, bottom, and top, and then we'll see what the layout engine does with those properties. We'll see. ACID2. Ooh, look at us. Wow, that was really fruitful. Awesome. I guess we had probably border these border things elsewhere as well, not only in the smile. But damned if that did not make some nice progress. So let's see. Let's just let's not add that bookmark quite like that, but let's add it at the tail of the bookmarks. So like that. And the GitHub link is just here because it's fun. It doesn't work that well yet, but we'll get there too. I guess it's nice to have some default bookmarks. Base, home and on bookmarks. Base, add a browser bookmarks. Put as a do test on the browser bookmarks bar. Yes, that is a sweet little thing. Okay, and this patch is very edgy and not super beautiful, but let's just roll with it. Expand border top right, bottom, left, into sub shorthand CSS shorthand properties. This code is pretty rough. But it's something that will also improve with the eventual new CSS parser. It's becoming like this excuse, but it is not. It's just the way things are going. So this is pretty awesome. I mean, it's as good as this has ever been. So what do we have going on now in the whole smile department? Let's go take a look. Smile is this guy right here. Okay, so smile is this guy right here. So it's actually pretty accurate. We have the same bounding box, sort of. And then what's inside of it? Smile. I'm still missing like these guys right here. So what's up with that? What's inside of here? The background, the div inside the smile, that's this guy right here. Click, click. Why don't we see those? Oops. There's so many different things going on here. So he has this background, and his width is 12M. And then I guess this guy here is the yellow guy. So what if you were not yellow, then everything would be black, right? Huh. Well, I don't know why, but okay, so what comes after that though? It's the chin, right? So the chin has a data URL background, which we do not support because we just don't know how to parse it. Background color. We have background color yellow. Wait, what is this image then? It's red. Oh, okay. So in our case, it's fine that we don't show it because it would have been red otherwise. So the chin actually looks decent because it even has the parts on the side here. And there's something on the bottom they're calling the parser container. For us, that's a big hunk of nothing. Is that something that we could improve, maybe? So parser container has nothing. Okay, fine. Parser has a whole bunch of things matched on it, including this guy right here, which is 2M, but it's some property we don't recognize. Is it the width? No. Wait, back up. Parser has a comment inside it. That's true. Okay. So what is this property? Invalid property ID 2M. It's not width because we can handle width. Oh, maybe it's this thing right here. Border width. 0 to M. I don't know if we can handle that one. Okay, so border color should be black. Because anything in the parser container should have border color black. This guy doesn't have border color black. He has border color red. which he gets from, I don't even know where, from here, I guess, from the parser selector. So parser container star, I wonder, it's an inline style, okay. Or wait, no, hold on. It's parser container border color black. Oh, I guess we fixed that one accidentally too by, oh no, we didn't, but we could. Or is this a valid property? I don't think it is. Okay, let's not worry about this one. But this guy right here. So we're matching a whole bunch of things. I think we're possibly matching this selector. It's just that that it then goes further down and matches another selector here, turning it red. Or not this one. Probably this one. And that's not super good for us, but this one should match because it has higher specificity. But I think we don't care about specificity in our engine at the moment. I don't even remember if we did anything with it. We can compute the specificity, but we don't do anything with it. Wait, so how does that work again? Let me look that up. Specificity. Specificity.com. Wait, does that? Oh, I forget how this works. Does that mean that only the more specific selectors should match, or that both should match just in different order? So what if we had like a not very specific selector div? I'm a div, right? So we had the div selector, not super specific, and it says background is red, right? And then the foo selector says background is green. So if div has id foo, then in this case, we should definitely get a green background, right? But what if the div selector specifies something else, like color white? Then okay, so specificity determines the order that we apply the style from the different declarations here, or the different rules, I guess, terminology. Well, we still have to apply them just in order of specificity. So how do we do that? We can compute the specificity of a selector by asking for it. That's good. So who has selectors? Style rule has a vector of selector. That's good. So when we're matching, let's see, how do we want this to work? I guess the easiest thing to do would be first you collect all of the matching selectors, or the matching rules, and then you order them by specificity, and then you apply them one at a time to the element. So how would that work? The selector has specificity. That's good. It's an enum. No, it's a class. Cool. And look at that. I've been such a good boy, like making these little things here for my future self. Thank you, past Andreas. So where's the outer thing of this? That would be in styled resolver, I think. Yeah. So we collect the matching rules for an element. This is how we resolve the matching style for a given element. We call collect matching rules, which will give you back a vector of matching style rules. And who calls this? It's Mr. Resolve Style. So Mr. Resolve Style has to, what must he do? Set property, blah, blah, blah. So this just expands all the shorthands and this and that. That's fine. So maybe we should do a step here where we reorder the vector based on specificity. So what would the naive way to do that be? Because there's one big problem here, which is that a style rule can have multiple selectors attached to it. So in our case, these style rules that we wrote here, oh wait, set no new is what I wanted. So if you're not familiar with the terminology here, so this here is a rule, and this here is a selector, and this is a declaration, and this is a property. So each rule can have multiple selectors. So you could have foo and bar, two selectors with the same rule. Now, this causes a little problem for what we're going to do now, because depending on which of these selectors in a given rule your element matched, specificity is different, right? So there's no such thing as the specificity of a rule. There's the specificity of a selector. And it totally depends on which of its selectors you matched. So let's just skip over that though right now, because I don't want to deal with that aspect right this very moment. So we'll just pretend that the first selector in a rule determines the specificity of the entire rule. So maybe we can even do a quick sort, actually. Quick sort, quiche sort, quick sort. Quick sort of the matching rules with a comparator, which compares A and B, which I guess will be references to something, will be references to rules in this case. And what we'll do is we'll check A, hold on, let's see, style rule A dot selectors dot first dot specificity. So B dot selectors dot first dot specificity. Let's see if that works. This is such a hack, but I mean, it's a hack and it's not a hack, right? So let's see if it actually does anything good. It did not do much good. It totally falls apart because we are doing what exactly goes wrong here? We're doing a quick sort over what? Over a non-null ref pair vector. So we're crashing inside quicksort. It's doing something stupid. The dual pivot quicksort. Oh man, somebody somebody changed the quicksort implementation a while back to something that was supposed to be faster, and maybe it is, but now we are doing something that appears to be wrong because we are we're crashing because we're in the destructor of a style rule, and it has non-zero ref count. No, that's not good. But we are an act swap of two style rule pointers. That's not right. Oh, shite. I guess because we're using a non-null ref putter vector, then this is, oh, that's so deceptive. So non-null ref putter vector is a convenience class that overrides stuff like the bracket operator and gives you a t-amp rather than a t-star, which is what you would get from a regular vector containing non-null own putters or non-null ref putters. So it's really just to sort of codify that a vector has non-null pointers in it and allow you to use the dot operator rather than the arrow operator to dereference indexes. But in this case, it actually totally screws up quicksort because quicksort just tries to swap two indexes in the container being quicksorted, and then we end up selecting an implementation of swap here that tries to swap two style rule objects with each other. So I wonder if we could we provoke this thing to not work somehow? If we make it like non-copyable, which it should be non-copyable, non-movable in the first place since it's reference counted, but let's just see what happens if we do that, because I'm kind of curious if that provokes compile error. Style resolver 446. I think that would be it. 446. Yeah, right. So if we had marked it as non-movable, non-copyable, we would have had a failure here. So I think that's good. Of course, the main issue is that we can't quicksort on a non-null putter vector, which is irritating. So what if we just reinterpret cast it? Can I spell it? Reinterpret cast to vector of non-null own putter to style rule, or are they ref putter perhaps? Yes, of course they are. Non-null ref putter. So we cast the matching rules to that. Type it cannot have a name. What am I doing wrong here? Okay. Oh, yeah, right. I can't, I have to reinterpret cast to a reference to that type of vector. Vector. There we go. C++. Okay, so now we have to use the aforementioned arrow operator. This is some semi-deep C++ problem here, but this should do the trick. Man, I wonder what's a good solution to not have this problem. Maybe we should allow you to do, I mean, obviously we need to allow you to do quicksort on a non-null putter vector, but maybe we'll need to specialize something for that, or to make quicksort aware of these containers somehow. So, what did we achieve by doing this? I've completely forgotten what I was even trying to do. I wanted to, Hello. Wanted to make some new selector match something, and I thought that I was doing that correctly by changing the specificity thingy so that we apply them in order of specificity, and this was the parser thing, right? So the parser now has black borders correctly, although that doesn't really seem to achieve much. I don't know why. It has some goofy, I don't know what color that is, maybe orange or something. But we do have black borders. Borders are solid, and the border width, oh, this is something that we didn't parse correctly. Interesting. So we could probably teach it how to parse those. So border top. What does it mean when you have 0 and then another pair of values? 0 to m. Border top width. Probably it's like the vertical borders and the horizontal borders. Please give spec. Value can be a border width value. Okay. What is a border width? One through 4. Okay, so you can have up to 4 of them. What on earth does that mean? It's a shorthand property setting top width, right width, bottom width, and left width at the same time. Wait. Border with 2 values. I'm a bit confused about which is what. Two values. Top, bottom, left, right. Okay. So vertical and then horizontal. So let's see how we would interpret that in the shorthand thingy. So that will be when we are doing border width. So here, I guess we need to look at the value. So we'll do split on white space, value to string, and then if parts size is 2, then do XYZ, otherwise do the old thing. So if we have 2 parts, then what we want to do is vertical border width is parse CSS value parts 0, and the horizontal border width is part 1. And then we just set the properties according to these. So this would be the vertical border width, this guy is the horizontal, and likewise for bottom and left. Ooh, look at that! Oh man, his his little cheek is taking, or his chin is taking a little bit of shape here. I don't even know what part of the face that is in English. Anyway, whatever they call that part is it's like this part right here. So The very bottom of his chin is weird looking. Presumably it's this one. Oh, it's multiple parts. First part, second part, third part, fourth part. Oh shit, look at that. It's a display table. That's why we're putting them like that, probably, because we don't have table layout at all. Okay. Very interesting. This gap here, wonder what that's about. Anyway, making nice progress here, I would say. But let's see. So yeah, let's put a big fix me around that quick sort thingy. Fix me. It's really awkward that non-null ref vector cannot be quick sorted. Fix me. Actually, the bigger fix me is we need to look at the specificity of the matching selector, not just the matched rule. I guess like matching selector, not just the matched rule. Yeah. So that's a big fat fix me, but it's still an awesome little patch. So let's go ahead and commit that libweb. Apply style rules in order of specificity. Kinda. We now sort the matched rules by specificity of their first selector. The first selector. This is not perfect. This is not perfect since a rule can have multiple selectors. But it still does improve some stuff. So that's a really nice fix regardless, and we know where to go with it. You know, let's. But it is a nice chin-related progression on ACID2. Yeah. Okay, and then we also had the two-part border width property expansion. Web expand two-part border width shorthand CSS properties. Okay. So, should we throw in the eyes? That was an object element with those eyes in it. Although that was a weird one. So what's going on here? They have an object. Just display inline, display inline. I wonder what would happen if we just edited the test a tiny little bit. So we had these object elements. So what if the inner one was just a simple imgsrc? Like, what would happen? That didn't really load. All right, so why did that not load? Let's see if there was some stupid markup mistake there, but I think something about that was not working right. So here's our object, ing. What does the layout tree look like, I wonder? So object ing is 0 pixels wide and 150 tall. So that's the default intrinsic, I guess, behavior. Do we not support data URL? Wait, hold on just a moment here. What was going on with that markup anyway? What was I doing there? Data image pung. So that should kind of work, I would think. Let's isolate that. Data image. Base home non www, or we'll just put it here, HTML. So this will be just a document with nothing but that image thingy. And if you open that in Firefox, we get this. Okay, so it does not work correctly here. So this is a very nice little isolation of something that we can probably debug in isolation very nicely. Oh, wait, back up. Wait, why is it doing this? So we have an image. Resource did load. Interlaced PNG is not currently supported. Well, that's the issue. Okay. So that would need to be fixed in the PNG codec. Interlaced PNG. How does that even work? PNG specification, please. Interlace. Okay, so interlaced PNGs basically don't encode the pixels sequentially, but rather like with gaps. And the point of that is that then you can decode an approximation of the final image even before you have all the data, because you have like samples. And then as you get more data, you fill in the rest of the image. But I don't know if we're going to work on that now. Maybe we can hack our way out of this situation a little bit hackishly. Or you know what? Let's find something else to fix, because I don't want to get into context switching into the PNG stuff right now. So what else do we have? Oopsie doopsie. Okay, so what's going on up top? We have this address thing, blah, blah, blah. Forehead. So why is the forehead not yellow? I guess we can look at that. What makes the forehead yellow here? This is the forehead, and it's yellow because it has a background. I wonder if this one is also interlaced. I guess we can probably wait. Can we just do something with that? So background image. What do we do with background image? Maybe we don't support setting the background image via CSS. expanding shorthands. But what if you're setting, I think we can just kludge it here a little bit. Okay, so we already handled the background property here. So background, and we check if we have a color property, we do that one. But I guess if we have color, and then we can check if we also have a background image, we can try to use that. So maybe we'll just do this. If value is string, value to string. Hold on. So if it's not a string, return, or no, continue. And let's take a look at what the string actually is. So background sub property string. What is in there? Because I think it's going to be like URL paren or something like that, which we could then deal with. Background property, yeah, like this, URL paren and then data image, so and so. So we could actually parse that. Background image, what did we do here? Background style value, which is an image style value. Okay, all right. So it's an image style value that we construct. Okay, we can do this. So if we encounter something that starts with a URL thingy, starts with URL paren. So if it doesn't start with that, just continue. Okay, and then URL is string, substring view, URL paren. So that would be 4 steps in, and then string length -4. All right, that's the URL. And then we have to complete the URL against the current document. So how do we do that? How on earth do we do that? We need a document pointer here. So document, please. You always need the document if you want to resolve relative URLs, because many URLs are relative to whatever the document URL is, right? So here we need to actually pass. Do we have document? Yeah. So it's pretty straightforward. We just pass in the document, and then we can do. Background image value is image style value create, document complete URL document. And can this fail? It cannot fail. It should probably be able to fail, but right now it can't. So if, oh no, not if, style set property id background image value. All right. Where are we? Line 200. Wait, what? Too few arguments. When called from 456. Cool. So can we get some forehead yellow, I wonder? Oh, seg violation, seg fault. You did not like that. Wow, it's a crash in the PNG decoder of all things. That looks pretty bad, but that's a good find. Process chunk. Oh, we're gonna have to go on the PNG decoder anyway, it seems like. So where are we? Process chunk. Interlaced. What are we doing here? It's a read from an address that's far away, so 82 something. We're nowhere near that address in our allocations. So it's a bogus address, and we're 43 bytes into this function. So let's just look at what's there. That would be an apps browser. Oops, should have piped to less. All right. So what's going on? Process chunk. So we're before call to wrap bytes, so before here. Are we just in a totally bogus state here? I wonder. Do we have any? So let's define PNG debug and see what comes out. And actually, maybe we should put that guy in his own little document at the same time. So it was a background with an URL. This guy right here, yeah. So like that. Ching. Oh, maybe we have some gunk at the end that we were not supposed to have there. So I guess it should end like that. How does this even work? I'm not sure. We'll see, but we'll start with this. Did that work at all? I have no idea. Body, background. Okay, so that works. It's supposed to be yellow if we do that, so that'll be pretty easy to test. Crashy crash. There are so many different headers in this PNG, that's weird. Like, is this like an intentionally weird PNG also? I don't I don't know. Maybe it is. Background image. What if we... How do we save this intact? P, right? So, oopsie doopsie. So what is file.p PNG? Presumably that's the one. So what if we identify verbose? What's the thing we say? Verbose, right? Don't know what's going on this PNG. PNG dump. PNG check. Is that a thing? Punkt check. Please give me punkt check. I don't know what it does, but we'll take a look at it. It seems to dump out some interesting information about PNGs, which I would like to see right now. So, punkt check. Oh, is it okay? It's minus 220. I don't even know what that means. But according to this guy, we only have 3 chunks. So maybe we have totally the wrong idea. We find all these different chunks, which were not there. So what's going on? And where are we even? I want to see that output again. So it only has 3 separate chunks: iHeader, iDat, and iEnd. Or is this as verbose as it gets? Punkt check. Colorized output. Well, I'll take a look at that. Sure, print text chunks. Why not? Verbosely. Sure. Hit me with all the stuff. Okay, so we have 3 chunks. And if we open this thing right here, oh shit, wait, I'm being stupid. This is obviously like, the browser is loading many PNGs. Oh dude, I'm so dumb. Right, these are all the like toolbar icons and stuff. But at the end though, we crash here. So presumably this is the PNG that we failed to load. So what we do is we do the iHeader chunk. That's the first chunk right here. Length 13 matches R13. That's good. And then iDat comes, or I mean, this tells us that this is a 1x1, 8 bits per pixel, color type 2, la 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 la. And then comes the iDat chunk. It's 12 bytes. And then we die. So why do you die? This T is over. So how do we investigate this? So we are in process chunk, and we know that it's an iDat. Wait, so we printed out this stuff. Does that mean that we actually did process the iDat chunk, and we are at the end chunk, which is the iEnd, and it has a length of 0? Is that weird? Let's look at some of our typical PNGs that we deal with. How about our mouse cursor? iEnd is 0 length. That's not weird. All right. I guess we can say that we have finished parsing a chunk at some point. Maybe after we process an i.chunk, we'll just like do a little print here. Printf finished processing i.. Yeah, just to see if that comes out. Okay, so we finished the i.chunk and then we got some nonsense after that in the next chunk. Wonder why that is. Process chunk. Okay, so let's do the fuggly hackish thing. Get chunk size. Time for some printf debugging. Get chunk type. Get chunk data. And get chunk source. And then we'll see where we fail also. Oh, crap. Wonder what this is about. So we get all the way up to CRC and then we crash. All right. So we're trying to read the CRC from the streamer, but that don't work. If size remaining is less than t, then return false. Sure. So what is going on here? We die in this call. I wonder if we're doing something wrong here. Chunk data, wrap bytes, chunk data, chunk size. What is size remaining? It's an int. What if we go past the end here? That doesn't seem good. So like, let's assert that size remaining is at least positive. I mean, actually, that should have been guaranteed by this guy. Also, we don't do anything with it here. Why does it crash, I wonder? I guess we can look at the network order. So we try to read from the data pointer. We can print that out here. Printf read from data pointer. This will be very, very verbose, but that's okay. Data pointer. So we're reading from a bogus data pointer suddenly. So when we get the chunk size, we have a good data pointer, and then suddenly we have a crap data pointer. So something goes wrong. Is it that our data thingy is gigantic? I think maybe. Process chunk. Who is making the data pointer point so far away suddenly? Get chunk data. So we can dump it out here as well. Or printf. After wrap data putter. Okay, more printf debugging. Oops, PNG loader. We shouldn't be, I mean, I shouldn't be assuming anything at this point. We should just investigate what's actually happening. Okay, so after wrap, data pointer is ridiculous. Before wrap, it's not so bad. So presumably we are adding a huge count to this thing. That's a good discovery. So the chunk size, maybe it's stupidly huge. So the chunk size is something that we read out here. Also, this stuff here is very strangely organized. Oops. What is even going on? Printf chunk size. So it seems pretty possible that we are just reading out crap here. Oh, we don't need the chunk type actually. Yeah. So maybe we're just at a bad offset in the file for some reason. But I feel like the wrap bytes function does not fail correctly. Size remaining less than count. Oops. So chunk size is huge. So where are we doing this? So this function should really be taking a size d, and size remaining should be a size t, and we should be checking for overflow here instead. So if checked, what is that? Checked size t, addition would overflow. Wait. Let's not make this more complicated than it needs to be. So assert count is positive. So I guess we're coming in here with a negative count, and that's the problem. Yeah. So if count less than 0, return false. This code could be better in general, actually, but for now, let's just have that failure, and then what's going on? I wonder why our chunk size is totally the wrong thing here. I mean, that's the real question, is like why do we have a bad value for the chunk size? What is that value? Let's investigate. So hex of 21, 61, 19, 16, 80 is this beautiful number. All right. And if we hex dump C, the desktop PNG, we have 80 D1 2B00, 80 D1 2B00. So we are here in the I guess this is the start of a chunk, right? So 80 D1 2B00. What does that mean? And then we have these 3 bytes. So hold on. Maybe we are misinterpreting these bytes somehow. We need to look in the spec. What is the header? Chunks. Chunking. Chunk size. How do we know what the chunk size is? I forget how to read this spec, but we just have to figure it out. Okay, so PNG data stream, chunks. Okay, so we have the signature followed by a sequence of chunks. Chunk specifications. Okay. But what about the chunk header? Chunk type. Chunk types are 4-byte sequences. Sure. Chunk fields. The length, a 4-byte unsigned integer. The length counts only the data field, not itself, the chunk type, or the CRC. 0 is a valid length. We should treat the length as unsigned. Okay. So what did we have here? So that's 4 bytes, and then are we just off by 1 byte here? So like these 4 bytes, these 4 bytes should be 0, 0, 0. That's the length of the header. So we're like off by 3 bytes for some reason. That's the problem. Because then comes the chunk type. Okay, so why are we at the wrong place here? So when we did the IDAT chunk, the data chunk, then the length of that one was OC. So that's 12 bytes. And we had that information correct, right? So we said IDAT was 12. But by the time we get to this guy, we have advanced too much. Is that true? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 bytes followed by a 4-byte checksum. This field, blah, blah, blah. Okay. So I'm wondering if we're not advancing the cursor for some reason correctly, but it's so weird that we are 3 bytes off. Like we're here, of all places, when we should be here. But we got IDAT. And I guess we printed more about it this time, right? Chunk type IDAT, it's CRC, blah, blah, blah. So when we process the IDAT, we are just decompressing exactly as much data as we want, or not even decompressing, but just appending it to our compressed data buffer. And that's the only thing we do here. And then we go back to the loop where we process chunks, presumably. Right, so just decoding chunks. Chunk size. Okay, so let's see if we can add some output to the streamer helper thingy. Let's print out some, let's have something like offset that we can print, current offset or whatever. Data putter minus M original data putter, something like that. Okay, so then we can print out the offsets while we are reading. So here we'll say get chunk type at offset %e. Yeah, something like that. Okay, and let's see what comes out. I'm definitely feeling some security issues in this PNG decoder, but that's a whole separate story. That's not why we're here right now. So get chunk type at offset 53, and then we bail. But this chunk size is wrong, and chunk size was the one I wanted to see. Dang it. All right, get chunk size at but then we should be able to work out those individual offsets. So hex dump desktop p. Okay, you actual jerk, what's going on? IDAT. Chunk size is 12. At offset 25, so I guess this is 16. Wait. No, this is the chunk we're looking at. After IDAT, we're at 49. So this is 0, 16, 32, 48. Does that even make sense? $49? I feel like I'm not calculating this correctly. So our first thing was iHeader. And that's getting a chunk type at offset 4. Oh, okay. So we're not, offset is not into the file, but it's into something else. The streamer points at data putter. So it's the, the header. We have to skip over the header. So the header is 8 bytes. So we have to add 8 to these numbers. Now it'll be easier if we just add 8 here. So that we can see the correct file offset. Otherwise this gets really confusing. But yeah, the PNG header is not part of the stream of chunks. So just do a little stupid arithmetic here to skip over it. All right, so get chunk type at offset 37. That's where the IDAT is, and then chunk size at 57 is where the next guy is. So IDAT was at 37. So this is 0, 16, 32. Get chunk size. No, chunk type was at 37. Chunk size was at 33. So 33 is here. This is the chunk size for IDAT. That's good. And then IDAT name is here. That's great. And then get chunk CRC at 53, which is 14 after the CRC here. Wait, does that make sense? Chunk data at offset 41. So, let's annotate this. This is kind of frustrating. Do we have a hex editor of some kind? Maybe we don't. Okay, anyway, let's just do this, and we can annotate here. So this is 32. Means that this must be 40. Which makes this guy right here 48. This guy is 56. All right, so 57, which is where we get the chunk size for the end, is here. That's the correct offset as far as I know. So our offset into this thing is seemingly correct. Now I wonder if this is not the data that we have in our buffer then, because maybe what I'm hex dumping here doesn't match reality. So maybe we should dump out what we actually have. Just do a sanity check. How do we do that? Process chunk, blah, blah, blah. And who calls it? You called it. So maybe here we'll do this. So we'll say data size. So if I is not 0 and I modulo 16 is 0, then we'll printf a new line. Okay, and then otherwise we'll just do a O2X and a basic U8 context data at I. So this should allow us to see the data that we are looking at before we start parsing it. So now I'm a little bit suspicious that there's something wrong with the data. Alright, so this will be our file right here, 8950 and so forth. So the top row is a match. Second row, still pretty good. Third row, third row starts to go a little bit out of control here. After 41 comes 54, blah, 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 63. But then after this F8, there's a bunch of nonsense. 0361, that's not here. Now where the frick is that coming from? And then F01 FF63 is here. But there's like a hunk here, which is not supposed to be there. So I think that's definitely where our problem is coming from. So the input here is not good. But the input is from our base64 decoder, which I wrote, so it's my fault, just like everything else in this operating system. And I bet you that it's this butthole right here. It's percent encoded. I did not see that coming. So we need to percent decode. Oh man, I should have eyeballed the URL first. But yeah, it has percent encoding, which is totally valid in the URL, but I think we don't remove that before we do the base64 decode. So decode base64. Who calls this? It's Mr. Resource Loader. Data payload. Oh, I have to sneeze, I think. Oops. Excuse me. Okay, so I think when we store the data payload, we should probably URL decode it. Parser. I feel like that's gonna help. Because basically, there are these characters that you can't have in a URL, right? And the way that you get them into the URL anyway is that you percent encode them. And a percent encoded byte is just a percent character followed by 2 hexadecimal characters for the byte that you want to insert in the URL byte stream. So we have to take care to decode such things, if present, when encountering a data payload in a URL. Boom! Alright, so let's see how this works in the ACID test. I feel like that still didn't do what we wanted. What did I want? It was part of the forehead, right? Man, the sidetrack was pretty serious, but forehead, it now has an image, and the image is this thing right here. What does it end with? MCC. So it's this guy right here. Did that not parse correctly, I wonder? Home, and B, HTML, MCC. It seems like we captured the whole URL, although the parenthesis at the end is worrying. I think we have to lose the paren, so that's probably why we can't decode it correctly. So in the style resolver, where we do the background image thingy, so let's see, if not string ends with a paren, continue, and then we remove one extra character. And I just want to see that yellow forehead, and then I think we'll call it a day, because I'm getting pretty tired in my brain from random debugging. Ooh, look at that. It's a weird in-between state, but maybe that's okay. It's definitely progress, although I'm a bit surprised at how strange it looks. Let's see what it says. Because they're definitely showing some kind of background on the forehead. Wait, that's not the forehead? I don't even know what we're looking at now. Forehead. Well, yeah, actually, hold on. This is the forehead. Yeah. So the forehead is in place. I just got confused by this thing right here. But the forehead background is there. It's yellow. It's frickin' progress. That's amazing. And then we just got this other thing for free, which is really weird looking. What is that even? I'm not sure. I'm not even sure how to find it. I guess it's another PNG, presumably. So it's not the chin. There are not so many PNGs here, so could it be this one? The forehead has a PNG on it. Okay. So the forehead has a PNG, which 1x1 yellow pixel PNG. Shouldn't be that one. The eyes, maybe? I don't know. You know, we could actually take these and just copy paste them into our Firefox. That's just a single yellow. And by the way, we're not supporting any kind of background attachments and stuff. We'll just like repeat any background that we encounter. I don't know what I'm looking for. Anyway, I'm just gonna go ahead and say that we've made some pretty decent progress today, and I'm really happy with it. So let's end it here before I lose my marbles. But yeah. It's really fun to work on this type of stuff. So let's make a commit out of it. PNG loader definitely needs a little bit of work on just correctness and security precautions. So we'll have to come back to that. But if you want to exploit the PNG decoder and claim a bug bounty before I get there to fixing it, then it's a free $5 maybe. Anyway, if you can, what's the thing? If you can get it to execute arbitrary code in the browser when loading a remote web page, which is the bug bounty condition. So this one was about the background. Oh wait, no, it's the border property thing. Okay, let's just add these as we go. So the URL change first. Git commit. ACK. URL should early code the data URL payload. Otherwise, we can end up with %encoded nonsense in base 64 data, which does not decode correctly. That's accurate. So add P, no, and no. So this was the border change. why did we need the document for the border? I don't even remember. I needed the document for... Oh, no, hold on. I needed, the document was for the image so that we could complete the URL because it's a relative URL. Right. So we needed maybe all of those changes actually. Yeah. The web, respect, background, URL, expand background URL into background image URL. Yes. This gives us a yellow forehead on ACID2. All right. Oh man, I am a little bit tired, so we're gonna end it all here. But I'm really happy with the results that we were able to get today. So thank you very much for hanging out and for checking this out. If you find this type of stuff interesting, and I hope that you do, then this is certainly something you can learn a lot more about by hacking on it and trying to improve support. And I don't know what kind of challenges lie ahead. We'll just have to like incrementally work on it until it reaches the destination. But yeah. And for those of you that follow the channel, maybe you noticed I was not posting videos for a few days, but back again today, and I've done a bunch of boring refactoring off camera, so that was a nice little break, but it's also good to be back. Thank you very much for hanging out. I'm a little bit rusty on how to end videos, but it was good to make a video again. I'll see you guys next time. Bye.